The topic what we are going to learn is about zeroth law of thermodynamics. This law is also known as law of thermal equilibrium. Thermal means heat. So according to this law, if two systems, consider B and C, these two systems separately be separately in thermal equilibrium with A, and similarly C separately in thermal equilibrium with A, then the system B and C will also be in thermal equilibrium with each other. This is the principle by which the thermometers are also used. So what is this law? The law states that if two systems separately in thermal equilibrium with the third one, then they tend to be in thermal equilibrium with one another or with themselves. If two systems separately in thermal equilibrium with the third one, then they tend to be in thermal equilibrium with themselves. Next, this is the zeroth law of thermodynamics. It is given in book page number 195. Now consider the first law of thermodynamics. First law is also known as law of conservation of energy. So now consider when a system moves from state 1 to state 2, so the internal energy changes from U1 to U2. Therefore, change in internal energy given as del U is equal to, del means change, U means internal energy, is given as U2 minus U1, final minus initial. This internal energy change is brought about by either absorption of heat or evolution of heat, or work done by the system or work done on the system. Four processes: either heat absorbed or heat evolved, or work done by the system or work done on the system. Because the total energy of the system must remain constant, we can write the mathematical statement for the first law is del U is equal to Q plus W. This is the first law of thermodynamics. Now Q means amount of heat supplied to the system, W means work done on the system. There are also other statements of first law of thermodynamics, 5 definitions also given in a book. For example, one of the definition, heat and work are the two ways of changing a system's internal energy. This is one. Another, energy can either be created or destroyed. Such a way, 5 definitions given in the book. You can follow any one of the definition. Among the 5 definitions, you can learn any one or two, which is the easiest one you prefer, and you can learn any one or two of the statements given in book page number 197. Now the mathematical statement of the first law. So this is the mathematical statement, del U is equal to Q plus W. Case 1, if it is a cyclic process, del U is equal to 0. So the statement del U is equal to Q plus W, 0 is equal to Q plus W, so Q is equal to minus W. In other words, during a cyclic process, amount of heat absorbed by the system, minus W means absorbed, is equal, heat absorbed by the system is equal to work done by the system, minus negative sign, by the system. Case 2, if it is an isochoric process, isochoric means no change in volume, that is del V equal to 0. So del U is equal to Q plus W. W means work done, the value given as del U is equal to Q minus P into delta V, that is delta V is equal to 0. So 0 into P goes to 0. So del U is equal to Q. In other words, During an isochoric process, the amount of heat, Q means heat supplied to the system is converted to its internal energy. Case 3. For an adiabatic process, Q equal to 0. So, del U is equal to W. In other words, in adiabatic process, the decrease in internal energy is exactly equal to the work done by the system on its surroundings. Case 4. For an isobaric process, isobaric means no change in pressure, that is del Q is equal to Q plus W. So, del U is equal to Q minus P del V. P del V, in other words, in isobaric process, a part of the heat absorbed by the system is used for PV expansion and remaining is added to the internal energy of the system. So, there are 4 cases: cyclic process, isochoric process, adiabatic process, isobaric process. This is the mathematical statement of the first law of thermodynamics.